welcome to another episode of our Self-Build Hour. We are pleased to be joined by you today live, those of you who are in the audience listening today. My name is Jenny Chandela, and I am hosting this Self-Build Hour, and we're going to be we've invited Brian Singleton to come speak to us about the importance of airtightness and MVHR systems. As just a quick reminder to you about logistics, we will be recording this event today. So those of you who are here live, please use the Q&A function to enter your questions. You can enter those throughout Brian's presentation, but if you don't have that Q&A function enabled, feel free to use the chat. We'll also be putting information into the chat for you, resources during the talk that are relevant to the talk. So without further ado, I'm going to introduce Brian. He is a senior engineer and technical sales director with ADM Systems. ADM Systems have pioneered mechanical ventilation and heat recovery, and he's here to talk to you today about his experience working specifically with self-builders with this system, and some of the key components, things that you should be considering as you are looking to develop your new build home or even potentially a renovation, an airtight renovation. So with that, I will hand it over to you, Brian.
Okay, can you hear me, Jenny?
I can indeed.
Okay, thank you. And I'll just hopefully get this open. Thanks very much for the introduction, Jenny. I'm very pleased to be able to be invited and to be able to talk to you today about the importance of MVHR and where we sit in terms of the building airtight and ventilating right. So I think just a bit of background to who we are. ADM Systems have been around since the early 90s. We specialize in mechanical ventilation heat recovery systems. We're an independent company, not tied to any one manufacturer or product. So we select from quite a wide range of products, including passive house approved units. We do the full sort of service for people to choose from the menu. So we do initial proposals, we do full CAD designs, supply only and commissioning packages, supply and installation packages, technical support for those supply only packages, and commissioning and balancing, and also offer maintenance. So not everybody will want everything off that menu, but you choose what level of service you can get from ADM Systems. So we do have a network of accredited ventilation installers to cover all of the UK. So we cover everywhere, Scottish Islands down to the Channel Islands and everywhere in between. So, where does this all sit? I know this subject is probably covered by Alan and some of his team in other presentations, but I think it's important to reiterate what are the key components for low energy houses. So the fabric first approach. The fabric is where the major investment should be. That is the heavy lifter in all of this. That is the forever bit. So that should be the first step in terms of considering a low energy or passive house. So what leads on from that, airtightness is equally as important. So just as an example, basic building regs work to an air permeability figure of 10. A passive house is 0.6. It's quite a significant difference. And if you look at the the demand, the usage for basic regs houses in the UK, it's 140 kilowatt hour per square meter per year. A passive house is 15 kilowatt hour per square meter per year. So you might not get down to the 15, but most people considering low energy houses are getting close to that figure. It is an absolute massive difference between basic building regs and a low energy standard. And that should mean that the level of heat that you need for your building should be relatively small. Some passive houses only need 2.5, 3 kilowatt of heat. Low energy houses maybe is up to 4 or 5. It is a very, very small amount of heating to keep the occupants comfortable. But you need to ventilate right. So if you're building airtight, the right approach is MVHR. So why do we need to ventilate? So in an airtight house, uncontrolled ventilation can represent quite a high percentage of total heat loss from the fabric. It is a requirement for Part F and Part L of the building regulations. So you do have to have a ventilation strategy. By the way, just everything I'm going to say today, for those of you who are potentially doing renovations, stroke extension projects, the same principles and tenets will apply. Obviously, it's a little bit trickier for renovations, but we are seeing a huge increase in that type of project, and clients are applying the same low energy fabric first approaches to a renovation project. So please take on board everything, whether you're doing a new build or renovation. So the last one's probably the most important: indoor air quality and condensation control. We are spending increasingly amounts of time indoors. More people are working from home. In some houses now, 2 people are working from home. So properties are occupied almost 24/7, 365 days of the year. So air quality is very, very important. Unfortunately, as in a lot of the regulations for the UK, they're not really up to the standards of other countries in Europe and the rest of the world. So there are other measures in terms of ventilation that can be applied. But all of these are really the wrong approach for low energy homes. So in the building regulations, in Part F of the building regulations, the similar regulations in Scotland, there is a way you can get over the building reg lines by not having MVHR. So these are like extract fans or central extraction systems. They all require trickle vents in windows, which just promote cold drafts, make us less comfortable. Heating systems are constantly hunting for comfort temperatures. It's uncontrolled, so it's uncontrolled heat loss. And extract only really will compromise the other low energy key components. So if you do some of them and don't do all of them, then the low energy key component approach can actually start to fall down. So, and it's also been proven, studies have shown that extract only homes have poorer air quality. We tend to put barriers up in front of the things that are supposed to allow the building to breathe, and resultantly the effect is not created. So really this is a wrong approach for a low energy home. So what is MVHR? It's not a heating system. It's a question we get asked quite frequently, but it does complement the heating system. It considerably reduces the heat loss with controlled ventilation. It's not air conditioning. There are functions within the systems that will aid potential overheating, and there are some active cooling products available, which I'll touch on in a little while. What it is a balanced controlled ventilation system, provides the background ventilation throughout the property, constantly supplying filtered fresh air and extracting moisture, stale air, odors out of your property. and it recovers most of the heat that you generate. Now, when we started, the systems, the units around were pretty low technology and very low efficiencies. The products around now are 90% to 95% efficient. So in most systems, you're only losing about a degree or a degree and a half over through the system. And the big thing is there's no requirement for trickle ventilators. So people pay an eye-watering amount on window and door packages, and if they don't have MVHR, they then have to sort of rather butcher them at the top to allow trickle vents to be installed and for the for a non-MVHR approach to work. So again, no requirement for trickle vents on any system that has MVHR. So how does it work? Very simple graphic. There is a unit which it contains a heat exchanger. That's the thing that does the magic. So in this graphic, the red extraction points are primarily from wet rooms in the property. So your kitchens, your en-suites, your utilities, your WCs. Sometimes we may take air out of a non-wet area, such if you're having, for example, a cinema or a gym, which might benefit from some extraction. But generally, the extraction is from the wet rooms, constantly being extracted through the ductwork, through the unit, and then exhausted to atmosphere. So odors, moisture is exhausted out of the building. Then the supply air is brought in from a separate point. It then passes through the heat exchanger. And for the majority of the year, the warm air transfer from the extract transfers through the plates of the heat exchanger and tempers the incoming air. And then that's then distributed into the habitable spaces. So lounges, bedrooms, dining areas will be on the supply side. So some rooms will have extraction, some rooms will have supply. An open plan space like a kitchen, dining will have effectively extraction and supply in the same space. But most spaces, it's either one or the other. So as I was saying, the systems now are very, very efficient. The better bits of kit around are 90% plus efficient. It's worth touching on purge ventilation. So the MVHR very much provides the background ventilation for your property. Purge ventilation is defined in the building regulations and is in addition to the background ventilation rate, not instead of. So you purge your building primarily for overstuffiness, overheating, which is becoming an issue in airtight houses. And again, I'll touch on that subject shortly. And you achieve that by opening doors and windows on separate elevations. So you're doing that for a reason, as a primarily for overheating. It is allowed, it is part of the ventilation approach, it is part of the strategy, and it is encouraged in passive houses and low energy homes. So it's a bit of an urban myth that you can't open doors and windows in low energy homes. It is part of the strategy and works alongside the background rate that the MVHR provides. So just to emphasize, the effect of approaching the ventilation in a house. I am fortunate to live in Northumberland in a place called Newbiggin by the Sea. Right next to the sea, we're about 50-60 meters away. So about a couple of Januaries ago, I was rewriting presentation, and it was a very, very nasty day. So I took a couple of snapshots. So on the left, you have a snapshot from an app of a house which is 20 miles up the road from me. It's a SIPS build. They achieved an airtightness of beyond passive, so very, very comfortable. On the right is a snapshot of the weather. Opposite where we live, there are some new houses which were built in about 2016-17. No MVHR, extract only, trickle vents. So on the day in question, it's 3 degrees. The humidity outside is in the high 90s because it's rainy, sleety. So the house on the right, they're pulling air in at 3 degrees at 96% humidity because they've got fans that are running constantly. On the left, the elderly couple, and this is a retirement home, their extract air through the MVHR system is being measured at 21.5. It's 3 degrees outside. The supply air is 20. So the people on the left are really comfortable. The people on the left have very low energy bills. The people on the right have high energy bills and probably have poor indoor quality because of the approach that the developer took. So that's a good endorsement of MVHR against extract only. So we get asked, you know, how do we go about this? How do we get this sized? How do I know what the costs are going to be? So the initial specification can be done from PDF floor plans, sections, elevations. That's all you really need to get an idea of what the specification and the costs might look like for your property. So, you know, even at planning drawings, if the footprint does not change, that's a good time to engage with somebody to get some initial costs, assess the plans, and give you a proposal. It's the next stage where you need to start to looking to engage with an MVHR specialist. So I'd say about the right time for this is somewhere between planning approved drawings and building control or building warrant. By that time, you would have settled on the construction type, and even had some initial drawings done by engineers or kit suppliers if you're going down that route. So what's key for MVHR designers is knowing what that fabric is, knowing, seeing more detailed sections, elevations, construction drawings. What are your joists? Because that's a very important factor. Are there any structures such as steels? You know, do we know whether roof spaces, eave spaces are warm or cold? Potentially, are there any fire stopping requirements? But that is the sort of information that MVHR designers need. Some advice really is, once you got to that stage, engage early, pre-kit construction, and certainly pre-site start date. And this is a good reason why. This is a project we did with Alan and his team up in Fife. Very, very complicated floor zone, lots of steels, lots of joists to negotiate. So the client, you know, sensibly engaged early with ourselves in this case. All of what you can see was designed at a very early stage. This was actually designed probably a year before any ground was broken. But liaison was done with architects, liaison was done with clients, liaison was done with kit suppliers and engineers. And as you can see in the pictures, holes pre-drilled through steels. So by engaging early, that's what can be done. By not engaging early, that system would have been very, very difficult to accommodate into the building without compromising ceiling heights or having boxings. So once that's established and that information is available, your MVHR company should be able to do a detailed schematic, bespoke for your property. So in the snapshots you're seeing there, the design has been done. It has also been dropped into the kit manufacturer's joist layout. So that's a sort of level of detail you could expect out of a design. These designs can be done at early stages and can be revisited and reviewed sort of nearer to installation. But the spine of the design should look something like that, and that ultimately forms the installation guide for whoever is installing the systems. So a big question we get asked on efficiencies and particularly noise considerations. The first consideration really, particularly from well, efficiency and noise, is just ensure that the MVHR unit is sized correctly for the property. What can go wrong is it either gets sized correctly in the first place and gets value engineered. Somebody in the process says, I can do that for less. But the implication is that, yes, it may fulfill the ventilation requirement for the house, but it may be running at a very high percentage, which is not good for efficiency or for noise. So if you're on the cusp of between one model and another, slight over specification is better than under specification. So that's the first point of reference in terms of efficiency and noise. Any system should also have attenuation built into it. So there are lots of ways of doing it. There are ducting manifolds which are acoustic, and there are other silencers that can be built in. So these measures are to stop air noise traveling down ducts, so that when it gets to the points in the rooms, that there's no intrusive noise. Where you put the unit is obviously a consideration. So a couple of examples here of plant rooms. Plant room is a very good place to have a unit if you're having a plant room in. Something to consider if you've got drawings done already. Have a look at the size of your plant room, because what's drawn might not actually be big enough, not just for the MVHR kit, but there'll be other types of equipment in there, stuff to do with air source heat pumps, manifolds, the cylinders, that sort of thing. So I think Alan talks about this, that whatever the plant room is, at least add a third to the size, because you need to accommodate all of this equipment if that's going to be an option for locating the MVHR and your other bits of kit. Not everybody has the opportunity to have a plant room designed into their house. So quite often, somewhere like a utility space can be used. These are two examples where it was designed in early. There's still room for white goods. There's still room for cupboards and worktops, as well as the MVHR plant. Roof spaces, eave spaces are possible. There are maintenance requirements for the unit, which are pretty much taking filters out a couple of times a year. So access has to be considered. But if that's the only space for the unit, then that's possible. Just be conscious of, if you are putting them in roof and eave spaces, that where they are in proximity to bedrooms. So ducting systems, this is what we call a branch ducting system. Historically, MVHR systems back in the day were always based on branch ducting systems. This can be metal spiral wound ducting or plastic ducting. I have to say it's becoming less and less, very, very limited now, but it's still feasible if that works best in the property. The type of ducting systems that are almost the industry normal now are what we call radial duct systems. So they're very low velocity ducts, individual ducts rather than one big branch. They eliminate crosstalk between rooms, so that's a big advantage over branch ducting systems. But I think that probably the biggest advantage over branch ducting systems is the ease in which these radial systems are able to be installed. The product we're talking about is very much a self-install. Any trade can do it. self-builders do it. We have lots of clients who put this in themselves. They have the design, they have the technical backup to do it. So this type of ducting system lends themselves to a self-install, because there's no joins other than at the manifold and at the valve position. So there's very little weakness throughout the ducting system, and therefore very, very few mistakes can be made. One type of ducting system to be avoided categorically is flexible ducting. Some companies still put this forward as their base ducting system, but it has a very high resistance. The higher resistance to the system, the noisier it's going to be, the less efficient it's going to be, and it's going to cost you more to run. So sometimes short sections of flexible ducting have to be used off the top of a unit. The building regulations actually stipulate you should use no more than 300 mil of flexible ducting. This can be potentially an acoustic section of flexible ducting, but no more than 300 mil is what the building regs now say. So thermal duct options. If you're having an air tempering system, which I'll touch on shortly, then you need to insulate ducting. If you're having ducting going through cold roof spaces, then you need to insulate ducting. If your external duct runs always need insulating, no matter where they are in the property. Everybody's will be different as to how much insulation you need around your ducting. Control strategy, lots of different options depending on whose unit you look at. Most of the functions of the MVHR are automatic, so all of the product has integral humidity sensors which sense an increase in moisture and will turn the system up for a short period. You can boost them manually. There are other sensors. There are some boost switches which can be done. So it depends on the system. It depends on what you need in your house in terms of control. A big question we get asked: what happens in summer? Overheating. Now, I don't know where you all are in the process of your projects, but very likely moving forward, your project will have to also be run through Part O of the building regulations, which is a new document which came in June 2022. So that's to deal with overheating. So a good architect will be able to run your house through something like PHPP to project whether overheating is going to be an issue. Our advice is to mitigate first, and that comes out with the design. It comes out with orientation and shading and natural purge ventilation. Look at those first before applying any sort of mechanical options to overcome overheating. So this is a quick slide to show how the MVHR can help with what we call a summer bypass. So the house in question has obviously has a lot of solar gain. The bypass is 100% open. That the extract air coming out of the system is 26 degrees, so they're really melting in that house. There's cooler air outside. The bypass is open, so the supply air is about 2 or 3 degrees less than the extract air. So not air conditioning, but helping along with all of the other mitigating factors. There are some air tempering products. If you want to chuck a load of pounds at, it can more than double the cost of your MVHR system to apply some mechanical cooling. The products are there. I'm glad to discuss them to see if they're suitable. But it is an expensive add-on, and bearing in mind it's not air conditioning. And really, active cooling like air conditioning or this type of product sort of flies in the face of energy efficiency. Preheating is essential in an MVHR system, so this is to not contribute to the heat in into your house. It's to make sure that the system runs stably all year round, because if you don't have a preheater on an MVHR system, the likelihood is if it's still running, it's bringing a lot colder air in than you would desire, or it is totally shut down on the supply air to stop the heat exchanger and other workings freezing up. So absolutely essential to have a preheater on your MVHR system. So the installation process, I'm conscious of time, so I'll run through this pretty quickly. First fix, wind and watertight, preferably before other services. Second fix, walls, floors boarded and plastered. Commissioning and balancing as close as possible to you moving in, and also yourself to be available at commissioning and balancing for the handover. So some examples of first fix, the top two positions, you've got ducting run into air valve positions, ceiling and wall mounted. Then after the ceilings are boarded, these bits of black plenum are still stuck through the plasterboard, but they're cut back at that stage. And then what you actually see in the rooms is then applied. So all you see is ceiling mounted valves or wall mounted valves. There are some shaped alternatives as an upgrade. These are a couple of examples of where clients have actually painted over sort of more standard valves that have been supplied. So that is something you can do. Externally, what do we see? So these are wall grills, these are square louvers, or more what we call bullnose, which look a little bit like a boiler. A lot of these grills can be powder coated to match windows or to pick up stonework. So you choose what is most aesthetically pleasing for your property. You can go through the roof. We avoid supply air through the roof, potentially because of it adds to overheating. So exhaust air is possible through the roof. Just some further considerations. Kitchens, you have a recirculatory cooker hood. If you're having a wood burner, just make sure it's got its own air supply. Most of the product does now. And there can be some integration with building management systems. I've stuck this in just because it is becoming a little bit more of an issue. We're seeing more and more mention from building control of fire stopping. We don't particularly want to add additional costs to your MVHR system, but just be conscious of that and seek guidance from building control to see if it's required anywhere in your property. In summary, consider a system as early as possible. Make sure that whoever's doing it knows the rules and compliant. Can they give you the sort of full service through from proposal through to design and installation if you want, and commissioning and balancing. And I think the last one is probably the key one for me, is strive for air tightness and energy and efficiency. Going back to that early slide about the key components, don't compromise on any of them, because they all are interreliant. Some do more heavy lifting than others, but they are interreliant, and by dropping one or two of them out, you will compromise the potential effect and achieving a low energy home. So thank you for listening, and thank you, Jenny and Alan, for giving me the opportunity to talk today. I'm going to be around to answer any questions. Don't know where you all are on your journey, but whatever decisions you need to make, I wish you every success with your projects. And on that note, I'll hand back to Jenny.
Yeah, thank you very much, Brian. That was really, really helpful. It was a great overview from your early design considerations through what to expect during construction and what the finished appearance of the project and of the system could be and what variations are there. So I know we do have a few questions that have come in. So I'll start off with one of those and then hand it over to Alan for the full Q&A. So as a reminder, please do use that Q&A section, or if you don't have it, the chat section to ask questions of us. So the first question we have is related to fires that can happen in the home. It says, in the unfortunate event of a fire, what prevents the air ducting through the house spreading and feeding the fire?
A couple of things can be. One of the things that we can do is the units can be wired through the smoke alarms. So sometimes you may need an additional box of to do that. So if smoke alarms go off, then the fans will be shut down, so the system is no longer operating. Other fire stopping requirements, really, we need to take the lead from building control as to whether they're required. Traditionally, in a certainly 2-story and even in 3-story houses, there seems to be no requirement, but it is something, as I mentioned earlier, that is becoming more apparent. I think it's post-Grenfell. So products such as fire collars can be applied. The air valves that I showed you, they can be supplied as fire damper valves. So if temperatures were hit in terms of a fire, these things would close the ducts off or close the valves off.
Thank you very much. So we've got another question about, and this is a popular question when it comes to ventilation. I know I've heard yourself and Craig in conversations about it, asking about cooker head hood extractors. And how that integrates with the MVHR system, and are there any special considerations relative to rooms like kitchens, wet rooms, those sorts of things?
But certainly the recommendation in kitchens is to have a recirculatory cooking device. So whether that's an island with a pop-up, or Brora time downdraft, or if you're having a canopy, then all of that product will have the capabilities to have a recirculatory cooker hood, which will have carbon or grease filters. So that takes care of the grease, which we don't want to get into the MVHR system. It deflects the cleaned air back into the space, which is still warm and moist, and the MVHR then takes that away. Some people have elected to, I'm going to duct mine to atmosphere, so you can do that for the short time it's on. If they do that, then it won't really interfere with the effect of the MVHR system. But the main reason you don't want to do that, it's another bridge to outside. It's a thermal bridge, and if it's not shut off correctly, you've got a path from outside to in to allow cold air back into the property. So for that reason, I would go recirculatory.
And I think that brings up a really good point that ties back to the conversation about airtightness. So much of the time, people are striving for airtightness and have, sort of passive house standard, passive house principle goals. And yet they don't necessarily think about all the systems that are going to go into place, or their builder isn't aware of that airtightness criteria. And then things, on site during construction, decisions have to be made. You've got this airtight envelope, and suddenly someone wants to put another hole through it without the consideration of what effect that's going to have on the overall performance of the building. So really important to sort of plan early and to make sure everyone on the team, from design all the way through construction, is really aware of what it takes to get an airtight building and the importance of that.
Well, absolutely, Jenny. And just going back to, I think everybody on here can see the sense and the nonsense of applying MVHR or not MVHR, you know, and if you don't apply it, like the houses which are, you know, over my right hand shoulder, they've got 3 or 4 bathrooms in. They all have a puncture through the building.
Yeah.
The kitchen is also extracted to outside. So, you know, in some houses, 4 or 5 bed houses, you could have 5, 6, 7 extract fans all puncturing the building, all creating a thermal bridge, and all, you know, if they're not sealed right when they go through the fabric, compromising the air tightness.
Yeah, exactly. So there's a question about maintenance. It says, apart from cleaning and replacing the filters, what other maintenance would be anticipated for a system?
So the filters are something that the homeowner can do. Most systems are twice a year. There are people who want their system maintained once a year. So if you want an engineer to come and do that, then some inspection of the internal workings of the unit will be done. Heat exchanger perhaps taken out and you know, looked at and or cleaned. Although the filters really do their job and keep everything, you know, pretty clean inside. So other than filters ongoing, there's not a lot of maintenance required to the systems.
Do they have sort of annual just commissioning of the system that is required?
No, as long as you're keeping on top of the filters, you know, warranties will not be affected. It's not like a you know, a gas boiler which needs to have a certified engineer to sign it off every year. For some people, it's a comfort thing to have a service done annually. For some people, they can't get to the unit. They may be elderly or whatever. It may be in a loft or something like that. If it's a tenanted or rental, then, you know, the owner would rather have somebody come along and do it rather than the homeowner do it.
Alan, did you have any questions?
I think there was a follow on there from Neil Perry, who'd asked about the cooker hood question. He'd also asked, can you clean the filters?
Yeah, it depends who you talk to, Alan. Some manufacturers will say, don't try and clean them. Well, they would do, because they probably want to sell more. So I think if you get into a more frequent checking, then I don't see why you can't deep clean them and get maybe one more use out of them. Some people take the view of, no, I'm just going to go by what the manufacturer says, and every 6 months I'll pull those one out, put them in the bin, and just put some new ones in. So yeah, in my opinion, yes, but they have a lifespan. Depending on where you are in the country, will dictate, you know, how much they're going to get blocked up and how quickly.
And Brian, I don't know if you had said, but what's the typical cost for a set of replacement filters?
Well, the smaller, you know, the really small systems, you know, they're only about 30 quid a pair. The bigger systems can be 40, 45 quid. It's always worth a look online. Some people might do a deal if you buy 3 or 4 or 5 pairs at one go, and they might do a bit of a deal. All I'd say is, make sure you get the proper manufacturer filters, because there's looky-likey ones which block up after a month. So just make sure, particularly the top-end higher premium units, like the unit you've got in your office, Alan, you know, just make sure you get the right manufacturer filters and not a made-up one from abroad or elsewhere.
Yeah, and I think you've got to remember that we're putting this in for a specific reason, or a lot of different reasons with improvements, and these filters are the lungs of the house and the system. You wouldn't want to spend a reasonable amount of money and then cut corners on filters. I think from knowing filters I think you could probably clean them once, and after that it would be, I think they would be shot after that. I think you could probably, as you say, get an extra use out of them.
Yes.
But yeah, and yeah, definitely the right thing to do is keep everything up to date. And I think it is. I mean, it's really important to. A lot of people don't understand that there's a lot of expensive tech that goes into houses, and we often speak to people saying, well, I want an energy efficient home, and they say, well, what does that look like? And they say, well, it's got an air source heat pump and some bifold doors, and I know what kitchen I'm going to put in. But an MVHR is a must to me. It's not a negotiable. It's not on the desired list. It's on the, do you want windows? Do you want it to be warm? Well, I'm going to have an MVHR system. It's right up there with everything else, and it is. It's a simple piece of kit, isn't it, Brian? I mean, there's not, when we look at air source heat pumps and other big bits of tech, that they're expensive. There's a lot going on, and there's not a huge amount of people to service them. As you've said and alluded to, there's not a huge amount to do in an MVHR system.
No, not at all. And just going back to it's difficult. But colleagues and I have discussed many times. Air is a really difficult subject to try and communicate, because you can't see it. You generally can't feel it.
Mm-hmm.
You can't smell it usually. So it's imperceptible, and it's so, but it is really, really important. Air quality is really important now. As I said, more and more people are working from home, and you must see it in the designs of your projects, that a little home study is not a little home study cupboard now. It's quite a big space, and there could be one or two people working there with lots of bits of kit. So it's really important. And we've actually had projects, Alan, where non MVHR has been applied in. I can think of one particularly not too far away from you, with DMEV fans and trickle vents. And as you know, in Scotland, you've got to have a CO2 sensor in the property now. And it's normally put in the master bedroom, because that's usually where two people are putting, and the highest reading of CO2, 1,000 parts per million, is generally up to 1,000 is generally viewed as safe. Anything above that, then you've got poor air quality, and the thing pings, and the idea is, I'll go and open a window because I've got high CO2. The project in particular, they moved in, they were getting readings of 2,000 parts per million. He invested in a part MVHR system upstairs. The first night he turned it on, the readings were down to 900. So just by creating that air movement, mechanically, has dramatically had an effect on the air quality in that house. Whereas before, they was relying on extract fans and trickle vents. And one of the pictures in one of my slides is actually from that guy's house. He's put very heavy drapes in front of his windows. So how does the air get circulated? It doesn't.
Yeah, and I think people take air and breathing for granted sometimes. And in their homes, they've accepted that they've got, or they don't realise that they've got really poor air quality. And it's only, and I noticed the big difference, as you said, we've got a really nice Sender certified passive house unit in our office in Scotland, and the air quality in here is managed. It's clean, it's fresh, it's changed a lot. We've got a big volume in our building, and it moves about and it works really well. And I, as an asthma sufferer and somebody who hay fever and things become an issue, I notice it. I've noticed it massively, and the quality. And if you're in a room that's stuffy, you can start to feel headaches, or you're not at your most, you're not at your best anyway. So it just should be something that we all take for granted. And the filters. I mean, I don't know if you'd said about it, but what you're actually taking out from the filter that's taking the clean air in. If it wasn't there, it's not clean air that's coming in that filter. If that wasn't there, so if it's coming in through a window, you've still got the pollen, you've still got the spiders, you've still got the dust, you've still got the road pollution. that's taken out in the filter, and the stuff that's getting pulled around the house is that we see on the filters is a lot of it's dead skin, and it's other things and stuff that's carrying germs that's getting pulled about your house constantly. So these things are taken out by the filters. So I think I would urge everybody on the call that this is just something that is at the top of your list of needs, and not on the sort of desired nice to have part. It's just a thing that we must have. And I think that sort of falls on, Brian. I don't know if you did say too much about cost, but what is the typical unit if you said, say, an average 4-bed self-build, with a couple of en suites and a kitchen and utility room, 150 to 170 square meter home. You're using one unit, relatively simple plan, so you're not having to go across lots of different bridges and atriums that we like to design in, but a typical nothing assuming house. What would you be thinking is a sort of the start and end point in terms of costs? As a
it's the word we quite often get approached to say what's a typical 3-bed house, but I mean I've got 3-bed houses that are 280 square meters, and because they've got vast drawing rooms and whatever. Yeah. But I think to try and to be fair, so I mean if you took let's say somewhere between 150 180 square meter house, I would expect the range of products that we would supply, and we'd probably look at 3 manufacturers in a proposal letter and then discuss the merits with clients looking at their project. So you're probably looking at just over 5,000 as the intro one. That'd be a pretty basic model with really basic controls, older bit of kit that hasn't actually changed for 10 years, but still a bit of a workhorse and will do the job, through to about £1,000 more. So the one will be in the middle. I think after 180, so you then start kicking up to a slightly larger model to do the airflows. Going back to what I said about getting the specification right in the first place. Don't push the smaller model. So we would know, or we would look at a project and go, that warrants that one. But generally, I'd say like 190 up to 250, 260, maybe 270. You're then looking at 6 and a bit to 7 and a bit for basic model through to premium product. These are supply only prices, by the way. After 270, 280, you're into big houses. So you're looking at more single units, 8.5. If you're getting above 400, 450, 500 square meters, we need to talk. It's probably 2 units, as you know, Alan. We've got one project that we're working with you at the moment where it's got 4 units in, and those sort of projects are around. So, but I think the first 3 will probably cover about 90% of the self builds we see.
Yeah, and what's I think Jenny will be finishing up shortly, but I think you said that's at the supply only cost. How feasible is it for your average self builder to put in to install the ductwork, and how feasible actually is that?
It very, very. I mean, as you know, on some of the projects that we've worked with you over the years, clients have put it in. If they follow the design, we do support them as a company as much as we can, depending on location. We'll go to site. We will visit them pre-install or when they've got the kit there to run through. There's sort of buddy type services. So if you don't want a full install, you could maybe invest in an installer for a day to give you a helping hand and a guidance and a good start. And full installs are available as an option, and we can price on that. But it is. Just going back to the ducting systems, the radial systems really are a game changer for self-install, because you've got that type of system in your office. You plug one end into the air valve thing, the other end into the manifold. They're the only places that things can go wrong. Do things go wrong? Occasionally, but it's usually at the manifold and somebody's put the wrong duct on the wrong manifold, but that can be solved. So yeah, very much so. Self-install. Most of our work is supply only and commissioning, not necessarily always the clients, but certainly their trades, plumbers, electricians, general trades, all have put the systems in, and in pretty much all cases it works.
Excellent. Thanks for that, Brian. It's a good place to close it off, Jenny.
Yeah. No, thank you very much, Brian. That was really helpful. And I think, you know, for anyone who's thinking about embarking on this or is in the middle of it, it's a great reminder of what important elements there are within a low energy home and how important airtightness is, but also what that does for you in terms of your ventilation and everything. I've jotted down a few top tips in closing. So just as a reminder, an airtight house is going to require a ventilation strategy, typically a mechanical ventilation strategy. Airtightness is going to minimize heat loss. It's also going to maximize sort of indoor air quality and comfort through the use of a ventilation system. MVHR is not an air conditioning system. It's not a heating system. What it does provide is balanced and controlled ventilation, and early stage coordination is really key to success. This is coordination with the architect, with the MVHR designer, supplier, as well as with the builder. So thank you very much for your time today. As everyone knows, this has been recorded, so we will be posting it shortly, but we thank you all very much for your time and attention. As a reminder, there are a few live events coming up. The first one after the new year is in Farnborough. It's the HBR show from the 18th to 19th of January, and then the NSBRC, where I am right now today, is having their January show, which is the largest. It's a 3-day show from the 31st of January to the 2nd of February. And we will be joined next month, Thursday, 9th of January, with Marianne Messenger to talk about landscape design. She's an interior and landscape designer, but she's specifically going to speak to us about the importance engaging in landscape design early in your design process. So thank you all very much for your time and attention today, and for continuing to join us for these live events. We wish you all a festive season, and we will see you again in January.